Okay guys, so we are finishing 5.5, which is properties of rational exponents. We are on page 342, and we're skipping number 8 and going straight to problem 3, which is called boat speed. So we're going back to the boat. In the previous problem we were talking about buoyancy and the length of the, do you guys remember? The board or something. Now we're going to be talking about the speed of the boat. So here's the problem. The whole speed of a boat depends on the length of the hull at the waterline. The hull is like the front of the boat. An equation that relates the speed s in knots and the length r in feet of the hull at the waterline is s equals 1.34 square root r. Put a box around that because that's what we're going to be using for this problem. Okay? So the equation we're going to be working with is s equals 1.34 square root r. Okay? There we go, that's a little bit better. So here's what I want to know. What is the whole speed of the boat that has a length of 16 feet at the waterline? So, which one is the one we are solving for? Are we going to be solving for s, the speed, or r, the length? S, the speed, but we're going to plug in the length for which one? For r. So let's write that down. So s equals 1.34 square root, and what am I going to plug in for r? 16, good. Okay, we're going to do this one together. So this is going to be s equals 1.34 times, what's the square root of 16? 4, so times 4. That's just order of operations. We're doing the radicals, exponents first. So then what's the last step? Multiply. 1.34 times 4. Did anybody get that already? Anybody really fast? 5.36? You guys agree? Now what measure are we measuring speed in? Where does it say? Read the first part of the problem again. Find where it tells you what speed is measured in. Knots. Jonathan, do you know what knots are? It's boat speed. That's how anytime you're on a boat, the speed of the boat is measured in knots. It's a nautical thing. I don't know. But make sure that you're labeling it the right thing. So our boat is going 5.36 knots. That's its speed. Easy? So let's look at number 2. Number 2 wants us just to write an equation that you can use to determine the length of a boat at its waterline if the boat's speed is 6.7 knots. So here's what I want you guys to do. Plug what you know into the same equation, that's what we're using, and then tell me what you get. Okay, so where am I going to plug in 6.7? Is that s or is that r? That's s. So this should be 6.7 equals 1.34 square root r. Thumbs up if you got that. Excellent. So what do you think we're going to be solving for in this case? R. So number 3, let's go to the next page. Number 3 says to transform the equation to isolate the radical on one side of the equation. So what I want you guys to do, first rewrite the equation that we just had. 6.7 equals 1.34 square root r. So first we're just rewriting what we put in number 2. Now, all it wants us to do is to get the radical on one side of the equation. Just the radical. That means the r. So if I have 6.7 equals 1.34 times the square root of r, how would I get that square root r by itself? Divide by 1.34. So divide both sides by 1.34. Because these guys reduce. 6.7 divided by 1.34. Who has that? 5. So this is going to be 5 equals the square root of r. That's all they wanted us to do. Okay? That's all they wanted us to do. So then let's look at number 4. Number 4 says, what is the length of the boat at the waterline? How do you know? If the square root of r equals 5, what is r? Let's think about this, guys. The square root of r is 5. So what is r? 25. How do you know? Because the square root of 25 is 5. Write that in number 4. Okay? So the length at the water line is 25 feet. Because the square root of 25 is 5. Okay. When we were doing Pythagorean theorem, so I'm going to go back up to number 3 really quick and show you guys something. When we were doing Pythagorean theorem and we were solving to get rid of the squares, the exponent, what did we do? What was the opposite of squaring something? Square rooting it. So what do you think the opposite of square rooting something is? Squaring it. So when I end up with 5 equals the square root of r, what I can do is I can square both sides, because the square root and the square cancel, and 5 squared gives me what? So you would get 25 equals r. Okay? So that's kind of what we were doing. So let's look then at, we're going to go all the way down to the definition of a rational exponent. Now I know you guys ran out of room on your vocab sheet, so just highlight this in your book. A rational exponent is an exponent that is a rational number. You can write each nth root using a rational exponent, and then here's also what I want you to highlight. If n is an integer greater than 1, then the nth root of a equals a to the 1 over n. Okay? So we're going to be going back and forth between forms now. So highlight that in your books, please. So basically I'm introducing a new form to you. What I want you guys to do is rewrite this part, a to the 1 over n, just right next to the definition. And we're going to label some parts right now. Okay? The a, that's going to always be a number. That is your base. Okay? So I want you to label that your base. A is the base. That 1, the numerator in the fraction, is always going to be your exponent. In a lot of the cases that we're going to look at today, your exponent is always 1. It's not always going to be that way, but for our purposes today, it will be. Okay? But sometimes your exponent might be different. The n, the denominator, is your root or your index. Okay? So root slash index. It's the same thing. It's the number that's telling you what type of root you're taking, okay? So your root index is the denominator of the fraction, your exponent is the numerator, and the big number is your base. So here's what we're going to do. Part A. I'm going to do that one with you guys. So 7 is my base, so I'm going to write it really big. Right now we're taking the cube root of 7. 7 is my base, so that's your big number. Is there an exponent in this one? Well, here's your root. There's nothing being raised to the exponent, right? It's the same as saying an exponent of 1. So your numerator is going to be 1 because that's your exponent. What type of root are we taking? A third root. So that means my exponent is going to be 1 over 3. So 7 to the 1/3 power is the exact same as saying the third root of 7. It's just writing it in 2 different ways. That's all we're doing. Okay? So let's do B together. What is my base? X. So write that really big. What is my exponent? 1 in this case, because there's nothing there. Okay? We'll get to problems where it's going to be something besides 1. What root am I taking? A 5th root. So this is going to be 1 over 5. So the fifth root of x is the same as saying x to the 1/5. Does that make sense? We're just going back and forth between two different forms. Okay? Let's do c together, and then I'm going to have you guys do all of number 7 on your own. It's just the same but going the opposite way. So, what is my base in part C? Y. So write that really big. What's my exponent? 1, because it's the same as saying to the first power. So 1 over. Now what type of root am I taking there? Well, the regular root sign is what type of root? It's a square root, and that means you're looking for a number times itself twice. So that's going to be 1/2. So when it has nothing, it's a 2. Always. So what I'm going to have you guys do is I'm going to give you like 2 minutes. I'm going to have you do number 7 on your own. It's the exact same thing as number 6, but you're going the other way. So you're going to write each power as a radical this time. Okay? Alright, so let's look at number 7, guys. What is my base in this case? 8. So 8 is going to go inside the radical. My exponent is what? So do I have to write it? No. What type of root am I taking though? What's the denominator? 4. So that is a 4th root of 8. That's all I want. Easy? Okay. We're going to just be doing this for a while, okay? Let's look at B. What's the base in that one? Z. What type of radical am I taking? A 5th root. So this is the 5th root of Z. What's the exponent? 1. So we don't have to write it. C. What is the base of that one? M. Radical. What is my exponent? My exponent. 1. So do I have to write it? No. What root am I taking? 3rd. So that is the 3rd root of M. Raise your hand if you got all those right. Fabulous. Thumbs up. You guys good? Okay, so let's turn the page. So just to finish up this problem, let's look at number 8 really quick. Now it wants us to take the equation for the whole speed of the boat, which remember was S equals 1.34 square root R, and wants us to write it using a rational exponent. So really quickly, will you guys rewrite that? Instead of a root, use an exponent. So if I have a square root R, everybody, what would my exponent be? We actually did a problem just like this. The exponent is 1. What type of root am I taking? 2. So that's going to be R to the 1/2. These two are exactly the same. Square root of R and R to the 1/2 are exactly the same. The reason why we go back and forth is because sometimes you will see problems with an exponent, and sometimes you'll see them with a radical, but you need to be able to go between the two. Okay? So let's take a look at number 10. We're going to skip 9. Okay. Number 10 looks similar, but a little bit different. What's different about all of the problems in number 10? The exponent is not 1 anymore. So I'm going to do the first one with you guys, and then you guys are going to finish this on your own. Okay? So my base here is 4. So that's what goes inside the radical. What is my exponent? 3. So we're going to put the whole thing in parentheses and raise it to the 3rd power. What type of root am I taking in part A? 2. If I'm taking a square root, do I have to write the 2? No, that's the only time you don't have to. Okay? So here's what I want you guys to do. Finish B, C, and D on your own. Alright guys, so let's look at B. Part B, what is my base? 5. So that's what goes inside the radical. What is my exponent? 3. So 3 goes on the outside. And what type of root are we taking? 4. Thumbs up if you got that correct. The 4th root of 5, all of that to the 3rd power. Excellent. So I'm going to pick on a couple people. B, what'd you get for part C? So let me help you out. In part B, we read this as the fourth root of 5 to the third power. Okay, so then what would you get for C? Okay, so the fifth root of what? Of x. All of that to what power? To the fourth power. Good. Thumbs up if you agree. Excellent. Okay, so let's look at D. Anissa, what'd you get for D?
I'm not sure how to say it.
Okay, what type of root are we taking?
Okay.
It's okay, it's okay. What's my base?
The base is y.
The base is y. What exponent are we raising it to? 2. And what type of root are we taking? 3. Perfect. So is that what you got?
Yeah.
Okay, here's how we read it, guys. The third root of y to the second power. Will everybody repeat that after me? The third root of y to the second power. Do it again. Third root of y to the second power. Now without me. One more time. Perfect. Does that make sense? Okay. It is important to know how to read it. Okay. So let's go to number 11, and then we are done with 5.5, and 5.6 is really fast. So we're almost done. Number 11, we're basically doing the exact same thing, but we're going backwards. So in number 11, I have the fourth root of 2 to the third power. So here's how I would write it. 2 is my base. My exponent is 3, so that goes in the numerator, all over my root, which is 4. So the fourth root of 2 to the third power is the same as 2 to the 3/4 power. Can you guys say that? 2 to the 3/4 power. One more time. One more time, because not everybody was doing it. Excellent. Okay, I'm going to give you a minute. Finish B, C, and D for me. Part B, I have the square root of 5 to the 4th power. Jonathan, how did you rewrite that first? Yeah.
5 to the second.
5 to the second. How did you get 5 to the second? What was the step right before that?
Well, I got 5, 4 and 2, and I reduced 5 2 over 1, and then I got reduced that.
Perfect. Okay, so we're taking a square root, so that means that my index is actually 2, but we don't have to write it. But that's 4 to the 4th power all over the index, which is 2. So that was 5 to the 4 over 2. But 4 over 2 reduces to 2. So our answer would be 5 to the 2nd power. Can you guys do 5 to the 2nd?
Yeah.
Yeah, what is it? 25. But they wanted us to just leave it in exponent form, so this is an okay answer. Okay? Let's see, what about part C? Caleb, what'd you get for part C? X to the 8 over 5th power. Yes? Agree? Okay, and Brittany, what about D?
Y.
Mm-hmm.
Second.
Y to the 2nd. So how'd you get to Y to the 2nd?
Well, first I had y over 5.
Perfect.
So I reduced it.
Exactly. So we have Y to the 10 over 5. 10 over 5 reduces to 2. Okay? Thumbs up if you got all those right. Fabulous. So your homework for 5.5 is the skills practice, but I'm only making you do the odd ones. Was it even? So let me change it to even. You did them all? Then you got extra practice and you're going to ace the test.
I get extra credit.
Maybe.
Wait, so is it both of them
On both of them, you're just going to do the even.
Okay.
Yeah. So because I'm having you do 2 of them today and it's a lot, even though it doesn't take that long, you're just going to do the even. Now the vocab parts, I do want you to do all of the vocab section, but that's just matching. Okay? So on the vocab part, do the whole thing, but on the problems, just do the evens. Okay, I couldn't remember if I had said evens or odds. So, evens on that.